Okay, so part 2, number 15. I'm going to complete the square to put this into vertex form, but remember, you cannot use this method of completing the square unless the leading coefficient is 1. So I'm going to need to make this leading coefficient of 1. How am I going to do that? I'm going to divide everything by 2. So y over 2 equals x squared minus 2x minus 3. Now I've got everything divided by 2, and I've got a leading coefficient of 1. Now I'm going to use my technique. X squared minus 2x with the minus 3 moved all the way over. And I'm going to complete the square. So half of negative 2 is negative 1, and I need to square that. So that's 1. So I'm going to add 1 and subtract 1. Half of negative 2 is negative 1. Squared is 1. Now I can factor this perfect squared trinomial that I made by adding 1. Square root of x squared is x. Square root of 1 is 1. And I have a minus in here, so I'm going to need a minus here. Oops. It should be x. X minus 1. And I'm going to square that. And on the outside, I have minus 4. But I'm not done because I have y over 2 on the left-hand side. So everything has to get multiplied by 2 to get y back by itself. So y equals 2 times x minus 1 squared, and then also 2 times this term, which is negative 8. So 2 times outside the parentheses, and then 2 times this term out here. And that is the vertex form. Y equals 2 times the quantity x minus 1 squared minus 8. Well, what's the vertex from that vertex form? 1, negative 8. The axis of symmetry is x equal to 1, the x value here of the vertex, because it goes right through it. And then the y-intercept, again, it's not equal to negative 8 here. It's equal to the negative 6 up here in the standard form. If you want to find it from here, let x equal 0, and you will get negative 6. And so do the same thing here for number 16. Make that leading coefficient 1 first, and then employ the complete the squared technique. Okay. Long time ago, we had equations in standard form, and before we moved them into vertex form, we used a different technique. This was a long time ago, and I'd like you to practice it. How do we find the vertex and the axis of symmetry from the standard form without converting it into vertex form? Well, we're going to use the equation x equals the opposite of b over 2a to find the axis of symmetry. So the first thing you find is the axis of symmetry using x equals the opposite of b over 2a. So the opposite of b over 2 times 2, that becomes 4 over 4, and that becomes 1. So x is, I should put x equals, so x equals 1. That is the axis of symmetry. And then from the axis of symmetry, we can find the vertex. Remember, the axis of symmetry goes right through the vertex. So if we put this value of 1 into the equation, we'll get a y value, and that will be the y value of the vertex. So the x value of the vertex is 1. What is the y value? So we'll take the axis of symmetry value and put it into our equation. 2 times 1 squared minus 4 times 1 plus 3. That's 2 times 1 is 2, minus 4 plus 3. So that's negative 2 plus 3 is positive 1. So our y value, when we put in 1 into the equation, we're going to get out 1. So our vertex is at 1, 1. Okay. We have our axis of symmetry, we have our vertex. Now we just need to find the y-intercept. And remember, from the standard form, it's quite simple. It's just the c value, which is 3. You could let x equals 0 and solve, and you will also get 3. Okay, so there's the information for number 17. Find the axis of symmetry, then put that value into the equation to find your y value for the vertex, and then the y-intercept is quite simple to see. Okay, number 19. Sketch the graph of each function. Use any method. Now, for number 19, we could change this into vertex form, but I'm not going to do it that way. I'm going to go ahead and use the method I just showed you again, because you do need to know how to do it this way. And sometimes you get fractions when you try to complete the square, and really either way is fine. I think this time it would work to change it. Maybe I'll do it both ways. So number 19, I'm going to find the axis of symmetry using the way we just used first. Axis of symmetry is equal to the opposite of b over 2 times a. So that's equal to the opposite of 2 is positive 2, and a is 1, so that's 2 times 1. So the axis of symmetry is 1, x equals 1. I can sketch that in here. There's the axis of symmetry at x equals 1. Now I'll put that value into the equation to get out the y value for the vertex. We know the vertex is on here somewhere. Let's put 1 in and get the y value. So y equals 1 squared minus 2 times 1 plus 3. Well, that's 1 minus 2 plus 3. That's negative 1 plus 3 is positive 2. So my vertex is going to be at, my x value is 1 and my y value is 2. It's going to be at 1, 2. There's the vertex. Now this parabola is going to open up because this value right here is positive. So I know my parabola is going to open up. And I can find my y-intercept, which is 3. So I can plot my y-intercept, 3, and I can mirror it across the axis of symmetry. Now I have 3 points for my parabola. If I want to find an additional point, I can put in x equals negative 1 or x equals 3. I'll put in x equals 3 and see what value I get to get a fourth and fifth point. So when x equals 3, it's 3 squared minus 2 times 3 plus 3. That's 9 minus 6 plus 3. That's 3 plus 3. That's 6. So when I put x equals 3 into the function, I get out the value of 6. So I'm going to plot that point. 1, 2, 3, 1, 2, 3, 4, 5, 6. And I can hear that 1, 2, 1, 2. And there's the parabola. You'll notice it follows the pattern of the parent graph. Over 1, up 1, over 1, up 3, because this A is 1. So the A does not change the pattern in any way. So there's the pattern. Now if I was going to change this into vertex form, I would complete the square. So I'm going to just do that quickly. So you can do it either way. You could do what I just did by finding the axis of symmetry, then finding the vertex, which was 1, 2, and then by finding the y-intercept and then plotting additional points. Or you could do what the second way would be to change this into vertex form. X squared minus 2x with the plus 3 all the way over here. Half of negative 2 is negative 1. So I take negative 1 and square it, so that's plus 1 minus 1, plus 1 minus 1, and then I have the plus 3 out there. I'll factor the perfect square trinomial, x minus 1 squared with a plus 2 on the outside. And that is the vertex form. And notice our vertex, we can take, okay, so that's the vertex form. We can take our vertex right from there. It's at 1, 2, which is exactly what we found when I did the vertex the other way. So we have the vertex, and then we have the vertex form. We know the axis of symmetry, of course, is at x equals 1. And we know the y-intercept from the standard form is 3. We're going to get the same graph. But what's nice about the vertex form, of course, is once you get the vertex of 1, 2, you can just use your pattern